Hello guys! Welcome to Eureka's second episode of MATHBalik Tanaw. Today's episode is brought to you by yours truly, Kay, and our topic for today is hypothesis testing. Specifically, when is it appropriate to use the z-test or the t-test? So before we delve into the lesson proper, let's have a review of what exactly hypothesis testing is. It is a decision-making process to test claims regarding a population. So if you have a TV, you might have come across commercials which claim that brand X is subpar or is not as good as the brand that you're promoting. How do we test that claim? By this hypothesis testing. It has 6 steps, and it usually starts with the hypothesis, which is an inference which may or may not be true. Since it's a hassle to examine the entire population, we normally get a sample and draw a conclusion from there. And note, if you want a more detailed explanation or discussion on this lesson, please feel free to suggest that to us or send us a message here on Facebook. Let's start. So, what are the main differences between using the z-test and the t-test? And when is it appropriate to use the t-test or the z-test? Okay, starting with the sample size. If your sample size is greater than 30, you need to use the z-test. Meanwhile, if your sample is equal to or less than 30, you need to use the t-test. For step 1 of hypothesis testing, it's the same, regardless if it's the z-test you're using or the t-test. However, it would depend if it's two-tailed, left-tailed, or right-tailed. The hypothesis statement would vary. If you want to learn how to identify if it's two-tailed, left-tailed, and right-tailed, you can request it down below. For step 2, regarding the level of significance, or what we know as alpha, they differ. If it's the z-test, if it's two-tailed, you need to divide your alpha by 2. However, if it's right-tailed or left-tailed, it's the same, regardless if it's z-test or t-test. So for example, your alpha is 0.10 and it's two-tailed. So you need to divide it by 2. So let's compute that. 0.10 divided by 2 is equal to 0.05. However, if you're using the t-test, you're going to multiply your alpha by 2. So again, if your alpha is 0.1 and then we multiply it by 2, it's going to be 0.20. For step 3, they differ in terms of computing the critical values and the rejection region. For the z-test, you use the z-table as your basis. However, during the t-test, you need to consider the degree of freedom in your situation. So this is computed as n-1, which is your sample size minus 1. So for instance, if your sample size is 20, you need to subtract 1 to get 19. And using the t-table, you need to locate 19 and whatever tail it falls under. So is it one-tailed or two-tailed? Again, for more details, tell us if you want a more detailed lesson. For step 4, there's no difference between the z-test and the t-test. This is how you state the decision rule. And again, it depends if what situation your problem falls under. Is it two-tailed, left-tailed, or right-tailed? For step number 5, they are basically the same, except if you can notice on the denominator, we use sigma notation for the z-test, while for the t-test, we use s. However, they both represent the standard deviation. The only difference is sigma or O represents the standard deviation in a large sample size. Meanwhile, S is for the small sample size. For number 6 or step 6, we need to make a decision. So we need to state our conclusion. It's either we accept or reject HO based on our previous steps. Now, for the summary, we created a Venn diagram to show you the main difference and similarities of a z-test and a t-test. As you can see, under step 1, 4, 5, and 6, they are the same. However, they differ in terms of the sample size because again, z-test is for situations wherein the sample size is greater than 30, while t-test is for those situations wherein n, or the sample size, is less than or exactly equal to 30. For step 2, which is the computation of the level of significance, we need to divide alpha by 2, while in the t-test, we need to multiply it by 2. And lastly, for step 3, our basis is the z-table. While in a t-test, we need to consider the degree of freedom and use the t-table as our basis for computation. So that is all for today's MATHBalik. If you have any comments or suggestions, please do not hesitate to contact us in our official social media handles. So until next time, we hope this helped.